Hi guys, welcome back. I want us to look at today. I want us to look at chemical equilibrium graphs, analyzing them and understanding them, how to figure out which reaction has been favored, how to figure out which graph is for the forward reaction, which one is for the reverse reaction, right? Okay, let's start with the theory. If you look here, let's say we're looking at the reaction of N2 plus H2, balance that at equilibrium, forming NH3, right? And delta H is less than 0. Remember that delta H is given is for the forward reaction, which means the forward reaction must be exothermic and the reverse reaction must be endothermic, right? Now, let's look at the concentration versus time graph. How do you see, because we are using Le Chatelier's principle to explain how equilibrium is reinstated, right, after a disturbance has happened. So if you look at this part, a disturbance happens somewhere here, right? And then what happens after the disturbance is what helps us to understand which reaction was favored, and we can look at a concentration versus time graph and figure out which reaction was favored, right? So when you have that one sharp increase in either the reactants or the products, it means the concentration in this one, the concentration of the N2 was increased, right? And when that concentration of N2 was increased, that's a disturbance. Then afterwards, what happens? What happens is the concentration of N2 and H2 decreases and the concentration of NH3 increases, right? So to reinstate equilibrium, the forward reaction is favored. The forward reaction is favored. So that means you're expecting that the concentration of N2 and H2 is going to decrease while the concentration of NH3 is going to increase, right? So the forward reaction is favored. That's how we see it in a concentration versus time graph. While if you look at a reaction rate versus time graph, you'll see that after the disturbance has happened, one of the reaction rates has a sharp or a drastic increase, right? And then the other one increases gradually, and then you'll see here that equilibrium is reinstated again. So in this graph, what we can deduce is that the reaction that increases after the disturbance has happened is the reaction which has been favored. So since the forward reaction is favored, you will see that the forward reaction rate is going to increase, right? It's going to increase because now remember you have a lot of the particles per unit volume of the reactants now are there because you have a lot of that N2. So the system is trying to decrease that N2 concentration that you have now increased. So to use it up, you have to form the product, which means the forward reaction rate must increase, and then at some point the equilibrium is reinstated, right? So that's the first one, when we have a change in concentration. What about the same reaction we look at when the temperature is changed? One thing you'll notice is that with the temperature change, there is a gradual change in concentration, all the concentration. There isn't any spike or sharp increase or decrease, right? So you will see here that there's a gradual change. Remember we said that delta H is less than 0, which means that at the forward reaction we said it's exothermic and the reverse reaction is endothermic, right? We know that according to in order to, if you look at reactions, endothermic and exothermic reactions, if you remember that the exothermic reaction is the one that releases heat energy, the endothermic is the one where there is a net absorption of heat energy. So if I have introduced or increased the temperature right? Or if I have decreased the temperature, right? In order for equilibrium to be reinstated, it means that the reaction that is going to produce heat is the one that is going to be favored, which means that is the exothermic reaction, right? So how do we do that? How does that happen? How does it look in a graph? Here, a disturbance happened. Before we had equilibrium, the concentrations were remaining the same. And then they were constant. They were remaining at the same value. And then when you look at the disturbance, after the disturbance happened, the concentration of NH3 increased and the concentration of H2 decreased, which means since the concentration of NH3 increased, it means that the reaction producing NH3 is the one that was favored, which means in this instance the forward reaction was favored. What does that mean? Now if you think about it, it means that the temperature must have been decreased, because it's a decrease in temperature that favors the exothermic reaction, while an increase in temperature favors the endothermic reaction, right? Looking at it in a rate versus time graph, since you have decreased the temperature of the whole closed system, it means the particles, all of them, the average kinetic energy of the particles has decreased. So both the reaction rates are going to decrease, both the forward and the reverse reaction rate, right? But remember we said the forward reaction rate is the one that is favored. What does that mean? It means although both of them are going to decrease, the one that is favored should decrease less, right? The reaction rate of the favored reaction should still be higher than the reaction rate of the one that was not favored. So you will see that the forward reaction rate decreases less compared to the reverse reaction rate, right? I hope that is clear. So between these two, the one in blue is the one that is favored. And then looking again, what happens when you have a pressure change, right? Pressure change, you'll see that there is a sharp increase. If pressure is increased, then a sharp increase in all the concentrations, right? And then the reaction that produces the least number of gaseous moles is the one that is favored. If you remember there, we had N2, H2, 3, and then we had 2NH3. There are 4 gaseous moles here on the left, and there are 2 gaseous moles on the right. So it means the forward reaction produces 2 gaseous moles, the reverse reaction produces 4 gaseous moles. So if you increase the pressure, the reaction producing the least number of gaseous moles, which is the forward reaction, is the one that is favored, right? Then obviously if you increase the pressure by decreasing the volume, all the particles are now going to be closer together. So there are more particles per unit volume, right? Or rather the particles are closer together. The volume has been decreased, right? Then what does that mean? That means that you are having the reaction rate of both the reaction rates of both the reactions is going to increase, since all the particles are closer together. But the one that is favored, which in our instance is the forward reaction, is going to increase much more than the one that is not favored. So the forward reaction is going to increase more than the reverse reaction, right? Now let's look at what does introducing a catalyst, a positive catalyst, do? A positive catalyst does not favor any of the reactions, but it increases introducing or addition of a positive, a suitable positive catalyst, right? What does it do? It does not favor any of the reactions, but it increases the reaction rates of both the forward and the reverse reactions, right? Of both the forward and reverse reactions. What does that mean? That means that if I introduce a catalyst before equilibrium is reached, the reaction rate of both reactions is going to increase, so equilibrium should be reached faster than before. If I introduce a catalyst while the reaction is at equilibrium, then the reaction is still going to continue to be at equilibrium, but it's going to be at a faster rate. So you can see here both reaction rates are going to increase, and you're going to result in a higher rate than before, right? So that's introduction catalyst. Let's look at it in a question format to say, how do we tackle this in a question format? We're given here steam reacts with carbon at 1000 degrees Celsius according to the following balanced reaction. Then they say, let's leave the Kc value, let's go to the graph. The graph shows how the rates of the forward and reverse reactions change with time. The forward reaction is the one that is the solid line, and the reverse is the one with the dotted line, right? Let's analyze it together. T0, the rate of the reverse reaction when the reaction begins, the rate of the reverse reaction increases, the rate of the forward reaction decreases. T1, equilibrium is reached for the first time, and then a disturbance happens at T2 that results in which reaction being favored? The forward reaction, right? How can we see that? It has increased. The rate of the forward reaction has increased more than the rate of the reverse reaction, right? And then this can either be an increase in temperature or pressure, we don't know. And then afterwards, around here, equilibrium is reinstated again, around here. And then at T3, there's a change that happens. But that change results in both the forward and reverse reaction increasing and reaching a higher reaction rate. So it means that at T3, it must be that there is an addition of a suitable catalyst, right? Of a suitable positive catalyst. Okay, then let's look at give a reason why the rate of the forward reaction decreases. It's decreasing because the concentration of the reactants is decreasing, right? The reactants are being used up, and that means you have less particles available per unit volume and less effective collisions per unit time for the forward reaction, right? And then what change was made at T3? I've already spoken about that. There was an addition of a suitable catalyst. At time T2, they tell us that the temperature was increased. And then, is the forward reaction exothermic or endothermic? Refer to Le Chatelier's principle. Before deciding whether it's exothermic or endothermic, start by explaining or figuring out, using your theoretical knowledge to figure out what has happened, right? Let's start with temperature increase. According to our understanding, is that an increase in temperature favors which reaction? It favors the endothermic reaction. Favors the endothermic reaction, right? The endothermic reaction. And then if you look at this graph, which reaction is favored? The forward reaction in this graph, refer to the graph, the forward reaction rate increases more than the reverse reaction rate. More than the reverse reaction rate. Right? So what does that mean? It means the forward reaction is favored after the temperature was increased. Forward reaction is favored, right? And then now I can conclude to say it means that the forward reaction is endothermic. Forward reaction is endothermic. Okay, then you can go back now and say, answer this question. The forward reaction is endothermic. So reason before you answer endothermic or exothermic, right? I hope that is clear. I hope that the lesson has been helpful to you. Please subscribe, share with your friends who may find this helpful, and I'll see you on the next video.